In example 2C, the equation is 9 times x squared plus 4 times y squared is equal to 36. We are going to find the x and y intercepts algebraically, and then we are going to graph the equation by hand. All right, so we're going to start by finding the x-intercepts. Okay, so in order to find the x-intercepts, we need to set the y value equal to 0 and solve for x. Okay, so if we do that, here's the original equation. So we're going to go there, and everywhere you see a y, we're going to plug in 0 for it. So that's going to give us 9 times x squared plus 4 times, instead of y squared, y is 0, so we're going to get 0 squared is equal to 36. All right, so now we need to solve this for x. Okay, this is going to be 9x squared plus 4 times 0 squared. When you look at this term right here, only the 0 is being squared. So this is really 4 times 0 times 0. Okay, so this is going to tell us that 9x squared plus 0 is 36. So this all simplifies to be 9x squared is equal to 36. Okay, so how do you solve this for x? Okay, when you look at this, you have to be careful because there is a number in front of the x squared. So you probably see, the x squared, and you might automatically think, okay, let me take the square root. Okay, and you are going to have to do that, but you need to realize here that only the x is squared. Okay, there's no parentheses here. Had we had parentheses like this, then everything inside the parentheses would be squared. So the 9 would be squared and the x would be squared. But that's not what we have here. We don't have the parentheses. Okay, so since there's no parentheses, only what is immediately next to the square is squared. So since only the x is being squared, we need to isolate the x squared piece before we can take the square root. Okay, so what we need to do here, all right, let me rewrite it. X squared is being multiplied by 9, so we need to get rid of the 9 before we can take the square root. Okay, so since we're multiplying by 9, the opposite is to divide off the 9. Whatever you do to one side, you have to do to the other. Okay, so then your 9's on the left side will cancel and leave you with x squared. So x squared is going to be equal to 36 divided by 9. That is 4. All right. So now you have reached a point, and I'll come up here because I'm running out of room. Now we've reached the point where we have something squared equal to a number. So to undo the something squared, we need to take the square root of both sides. Okay, whatever you do to one side, you have to do to the other. But remember what I told you in a previous example. If you have something squared equal to a number and you take the square root, you cannot forget on the right side to put plus or minus out front. Okay, so on the left, the square and the square root will cancel, leaving x. And then we'll have the plus or minus out front on the right, and then the square root of 4 is 2. Okay, now think about it. Positive 2 times positive 2 gives you positive 4. Negative 2 times negative 2 also gives you positive 4. So both positive 2 and negative 2 will be an x-intercept here. Okay, so our x-intercepts, oops, here will be, and I'll write them in order as ordered pairs. Okay, your x value, the first one we'll write negative 2 is going to be an x-intercept. You write the x-coordinate is negative 2, and then the y value will be 0. And the other one will be, the x value will be positive 2 with a y value also of 0. Okay. All right, so now that we know the x-intercepts, we can plot them. They are going to be points on the graph of 9x squared plus 4y squared equals 36. So the x-intercepts, the graph is going to cross the, or touch the x-axis at negative 2 and positive 2. Okay, so you can see the x-intercepts on the picture. All right, so now I will go up, find some room here, and I will calculate the y-intercepts algebraically. All right, so if you are doing this algebraically, I am going to need to see you set x equal to 0 and solve for y. Okay, so go back to the original equation in yellow. Everywhere you see an x, you're going to replace it with 0. So we're going to get instead of 9 times x squared, we're going to have 9 times 0 squared plus 4 times y squared is equal to 36. Now we need to simplify and then try to isolate the y. All right, so this first piece, 9 times 0 squared, again, only the 0 is squared. So this is going to be 9 times 0 plus 4y squared is equal to 36. 9 times 0 is 0. And so this whole thing simplifies to be 4y squared is equal to 36. Okay, we need to solve this for y. Okay, this is very similar to what we saw with the x-intercept. The y is being squared here, not the 4. So before we can take the square root, we need to divide off the 4. Okay, so we're going to divide both sides by 4. That's going to leave you with y squared is equal to 36 divided by 4, which is 9. Now we are left with something squared equal to a number. So we can go ahead and take the square root of both sides, but remember to put the plus or minus out front on the square root of the number. Okay, the square and the square root undo each other on the left, so we're going to be left with y equals. Okay, and then on the right we'll have plus or minus the square root of 9 is 3. Okay, so you have two y-intercepts here. The graph will cross or touch the y-axis at -3 and +3. As ordered pairs, when you write x, y, remember if you look where my cursor is, the x value has to be 0. Okay, so our first y-intercept is going to have an x value of 0, and the y value will be -3. And then the other ordered pair, again, you'll have an x coordinate of 0, and the other y coordinate will be +3. Okay, we can plot these points. If you look at your y-axis, the graph will be crossing at -3, so right here, and +3. Okay, all right, so we've got our intercepts, both x-intercepts and y-intercepts. So at this point, I would like to complete the graph of this particular equation. So when we've worked examples 2a and 2b, we've made a table of values in order to complete the picture. I'm not going to do that here because the nature of the equation, it's a little tough to do that. You have to solve for y and all that stuff. So you've got these 4 points to rely on. Okay, and let me talk a little bit about the equation for a second. You've got an x squared and a y squared involved. Okay, and this is something you're going to see in section 2.3. We're going to do a unit on, or not a unit, we're going to do a section on circles. And part of the circle equation is seeing x squared and y squared. Okay, so this particular graph is not exactly a circle, but it's really close. Okay, so don't think that when you connect these 4 dots in the picture that it's going to be a diamond. Very rarely do you connect things with lines. Usually everything is very curvy. Okay, so this is actually going to be an oval. Okay, so I'm going to go ahead and connect the dots here, but I'm connecting it in this oval shape, and I'll talk really quickly about why it's not a circle. Okay, but this is going to be the graph. Okay, at this point, I wouldn't expect you to know that on your own. Okay, I'm just kind of telling you what to expect. Just keep in mind, you will see this when we do section 2.3. If you see an equation that has, the x squared and the y squared, and we'll talk about the specific format when we get there, but that's going to usually designate a circle. Okay. This particular equation does involve the x squared and the y squared, so it's kind of fitting that circle equation. But the reason that this guy is not a perfect circle is because when we plotted the intercepts, remember the x-intercepts were -2 and +2. So the distance from the origin on either side was 2 units. And then if you looked at the y-intercepts, they were -3 and +3. So the distance from the origin for each was 3 units. So horizontally, you're going a distance of 2 units from the origin, but vertically, you're going a distance of 3 units from the origin. So it's making an oval, not a circle. Okay, so that is what this particular graph looks like. Okay, so we've got the graph, and then we've got our x-intercepts, and we've got the y-intercepts. All right, let's try one more.